Hi, so this is Alexandra Miti Hoya, and this is my experiment 7 for data communications laboratory subject, and it is entitled Design and Implement a VLSM Addressing Scheme. So for the topology, so this is S1 or server 1, and BR1, BR2, and server 2. So here for the objectives, part 1 is to examine network requirements. Part 2, design the VLSM address scheme. Part 3, cable and configure the IPv4 network. So, background or scenario, VLSM was designed to avoid wasting IP addresses. With VLSM, a network is subnetted and resubnetted. This process can be repeated multiple times to create subnets of various sizes based on the number of hosts required in each subnet. Effective use of VLSM requires address planning. Excuse me. In this lab, we use IP address 192.168.33.128/25 network address to develop an address scheme for the network displayed in the topology diagram here. VLSM is used to meet the IPv4 addressing requirements. After you have designed the VLSM address scheme, you will configure the interfaces on the routers with the appropriate IP address information. The future LANs at BR2 will need to have addresses allocated, but no interfaces will be configured at this time. So there's just some notes here. So the required resources, we're required to have 2 routers, 2 switches, PC, one PC, console cables to configure the CISCO iOS device via the console ports, Ethernet and serial cables as shown in the topology, and also Windows calculator optional. For the instructions, part 1, examine network requirements. So in this part, we'll examine the requirements to develop a VLSM address scheme for the network displayed in the topology diagram using the 192.168.33.128/25 network address. So this step is important because it would help us in our in the future parts of this experiment, part 1 and part 2. So for step 1, determine how many host address and subnets are available. So there are 20 how many host addresses are available in a 25 network IP address? 126. What is the total number of host addresses needed in the topology diagram? 80. So I've already computed it here. I didn't included the solution. So how many subnets are needed in the network topology? We need 6 subnets. Part 2, determine the largest subnet. What is the subnet description? For example, BR1 or router 1 LAN or BR1 to BR2 link. So the answer is BR1 LAN or 40 hosts. Next, how many IP addresses are required in the largest subnet? We're required to have 40 IP addresses. Next, what subnet mask can support that many host addresses? This is the subnet mask /26 or 255.255.255.192. Next, how many total host addresses can that subnet mask support? 62. Can you subnet the 192.168.33.128/25 network address to support this subnet? Yes, you can. And what are the network addresses that will result from this subnetting? So the subnetting would result to these addresses. One is 128 and one is 192. This part. Use the first network address for the subnet. So the first network address for the subnet that we're going to use is of course this one. The first here is 128. Step 3, determine the second largest subnet. What is the subnet description? BR2 LAN or 25 host is the description of the second largest subnet. How many IP addresses are required for the second largest subnet? We are required to have 25 IP addresses. Sorry. Next, what subnet mask can support that many host address? So it can subnet mask that can support 25 IP addresses are /27 or these IP address. How many total host addresses can that subnet mask support? This can support a total of 30 subnet masks. Can you subnet the remaining subnet again and still support this subnet? Yes. What are the network addresses that would result from this subnetting? So the network addresses that would result from this subnetting are these addresses. And again, the first network address for this subnet is 192, as since this is the first one here in our subnetting. Step 4, determine the third largest subnet. What is the subnet description? The subnet description for the third largest subnet is BR2, IoT LAN, or it has 5 hosts. And the IP address, it has a required for the next largest subnet of 5 IP addresses. And the subnet mask that can support this many IP address is /29 or 255.255.255.248. And the total number of host address that this subnet mask can support are 6 host addresses. And for the question, can you subnet the remaining subnet again and still support this subnet? The answer is yes. And what are the network addresses that would result from this subnetting? So these are those network addresses. Next, if we are to note the first network address for the subnet, of course, this one, 0.244 here, and the second, 323, 232, sorry, and here, 232, and for the third network address, 240 here, there. So for step 5, determine the fourth largest subnet. So what is the subnet description? BR1 to BR2 link. So this is the last one. So it has 2 hosts. And how many IP addresses are required for the next largest subnet? It would require 2 IP addresses. And what subnet mask can support that many host addresses? So it can support 30. The subnet mask is 30/30 or 255.255.255.252. And this is the subnet mask that can support 2 IP addresses. So next question, how many total host addresses can that subnet mask support? So it can support 2 host addresses. And for the question, can you subnet the remaining subnet again and still support this subnet? Yes. And lastly, for the network addresses, so what are the network addresses that would result from this subnetting? These addresses. And the first subnet, of course, this one, 248. So for part 2, design the VLSM address scheme, calculate the subnet information. So that's for step 1. So we're asked to use the information that we obtained from part 1 here to fill in the following table. So we're given the subnet description, the number of hosts needed, and we need to fill the network address or CIDR, and the first host addresses, and the broadcast address. So now, for the BR1 or router 1 LAN, the network address is 192.168.33.128/25. The first host address is 0.129 and the broadcast address is 0.191. Next, for router 2 LAN, the number of hosts needed are 25 and the network address is 192. The first address is 193 and the broadcast address is 223. For the router 2 IoT LAN, number of hosts 5. Network address is 224. First host address is 225 and broadcast address is 231. For router 2 CCTV LAN, number of hosts needed are 4 and network address is 232. There, /29. Sorry, I forgot to mention these numbers. Next, for the first host address, it's 233 and the broadcast address is 239. For router 2 HVAC C2 LAN, number of hosts needed are 4 and network address is 0.240/29. The first host address is 0.241 and the broadcast address is 0.247. And lastly, for the BR1 to BR2 link, number of host address are 2. Network address is 0.248/30 and the first host address is 0.249 and the broadcast address is 0.251. 1. Again, these IP addresses were obtained and solved through the information that we got from part 1, or this one, examine the network requirements. Step 2, we need to complete the device interface address table. So assign the first host address in the subnet to the Ethernet interfaces. BR1 should be assigned the first host address in the BR1 to BR2 link. So for the devices, we have BR1 and BR2 here. The interface used as based from our topology here. Excuse me. The IP addresses are equivalent, so let's see that one by one. So for router 1, interface is 000 and IP address is 0.249. The subnet mask is 252 and the device interface is BR1 to BR2 link. Also, BR1 used interface 001 and the IP address here is 1.129 and subnet mask is 0.192. Device interface is 40 host LAN. For BR2, interface is 000, IP address equivalent to that is 0.250 and subnet mask is 0.252. Device interface is BR1 to BR2 link. For BR2 001 interface, the IP address is 0.193 and the subnet mask is 0.224. Device interface is 25 host LAN. So for part 3, cable and configure the IPv4 network. So now that we have our IP addresses, we can now cable our network to match the topology and configure the 3 routers using the VLSM address scheme that, just like what I mentioned, what we got here from part 2. So now, for step 1, cable the network as shown in the topology. So this is our topology here, and this is our CISCO packet tracer. So for step 2, we need to configure basic settings on each router. So first, let me cable the network as shown in the topology here. So now that we're here in our packet tracer, so this is our topology. We need to make the connection that is here in our topology here on our wiring closet. So as you can see, this is PC1. We have here PC2. These are the servers, server 1 and server 2, and router 1 and router 2. So what we need to do first is connect server 1 here and BR1, BR2 next to it, and server 2. Also, we need to get our PC and put it here. As you can see here, this is the Zoom connection of our the main wiring closet, and this is the network topology. As you can observe, server 1 is connected to BR1 through fast Ethernet 05 and gigabit Ethernet 001. So we need to connect this server 1 to BR1 here using our copper straight through cable. So here we need to find fast Ethernet, what again, 05 there, and connect it to gigabit Ethernet 001 here. Now next, BR1, this is our BR1, right? We need to connect it to BR2 or here through gigabit Ethernet 000 and gigabit Ethernet gigabit Ethernet 000 in BR2. So again, we need to use our copper straight through cable here and find 000 here and connect it to 000 of our BR2 there. Next, BR2 is going to be connected to the second server here through gigabit Ethernet 001 and to F05 of to fast Ethernet 05 of server 2. So to do that, we need another straight through cable from 001 to fast Ethernet 05. There. After I've connected the servers and the routers together, we need to connect. Let me zoom out. we need to connect this connection here to our PC. So to do that, we need a console cable. So this is our console cable, the blue one, and we need to find the console port here in our router and connect it to the PC in RS232. And the same goes for server router 2. Rather, here we need another console cable and connect it to the second PC. Now that we have finished the connection, we can turn on the PCs. So let me just zoom out. Let's turn this on, and it is already on. So, and also the routers. So for step 2, configure basic settings on each router. So step 1, the cable network, we've already done that. So for the basic settings on each router, we need to assign the correct device name to each of the 2 routers, assign class as the privilege EXEC encrypted password for both routers, and assign CISCO as the console password and enable login for the routers. Also, we need to assign CISCO as the VTY password and enable login for the routers, and encrypt the plain text passwords for the routers. Also, we need to create a banner that will warn everyone accessing the device that unauthorized access is prohibited on both routers. So let's do that. So now that we have turned on the PC and the routers, we can now configure our router through our PC. So what we need to do is click on our PC and click on desktop terminal. So it would ask us, would you like to enter the initial configuration dialog? So no, and press enter on your keyboard. And here we need to configure our router 1. So enable config D, and host name is VR1. So VR1 line console 0, and password is CISCO. So let's check here. There's CISCO. So log in, exit, and we have line VTY 0 to 15. Password is CISCO. There. And log in again, exit, and we need to have our secret password class. So we need to enable secret class and service password encryption, and of course our banner here for demo TD. Authorized access only. Let's put a warning. Authorized access only. And exit. So now we need to configure the interfaces on each network. So gigabit 000 and gigabit 001. So to do that, we need to type on VR1 config D and int G0/000 and config IP address 192.168.33.249 and 255.255.255.252. Next, description is VR1 BR12 PR2 link there, and no shutdown. Okay, exit. Now interface for gigabit Ethernet G001 to have IP address 192.168.33.129 and 255.255.192, and description is 40 host LAN Next, show IP in brief. Exit and show IP. So as you can observe here, we have changed our interface in our gigabit 000 and gigabit 001. So as you can observe, it is already 192.168.33249 and 192.168.33192. So now let's exit and there show run. Start. Copy run start rather. There. And we're done. So next, what we need to do is repeat the same process to PC2. So let's close PC1, click on PC2, desktop terminal, okay, and again here, no, and router, enable, config T, and hostname is BR2 for this is an our router 2, and line console 0, password is CISCO, login, exit, BTY 015, oops, sorry, line BTY 015, password is also CISCO, and login, exit. And now for the secret, let's enable secret password class and service password encryption, and the banner MOTD is of course warning, authorized access only. There. After that, oops, sorry, banner MOTD warning, authorized access only. After that, exit and show IP in brief, PR2 hashtag. So now we need to configure the interfaces. So to do that, again, config T, and in our ID G0/000 your Ethernet, as you can observe here, it is unassigned, so we need to assign an IP address. So let's assign IP address for G000. Address is 192.168.33.250, and subnet is 255.255 and 252. Next, oops, sorry, I forgot the IP, to type IP. Let's repeat that. IP here, address 192.168. Description is BR2, BR1. Link, no shutdown, and 4 gigabit 001. IP address is 192.168.33.193. Description is 25 host LAN. No shutdown. And exit. Exit. Show run. run start. Okay. So as you can observe here, my completion is at 90% only. If I check on my results, excuse me, gigabit Ethernet is at 000. So let me just recheck that. So for us to check that, we need to click on VR2 here, and click on exit. And let's check show IP brief. So there, as you can see, gigabit 000 is unassigned. So let me just repeat that. So enable. So for our VR2, let's configure the interface. So config T, and INT for the interface in our G000. Let's change the IP address to 192.168.33.250, and 255.252 is the subnet mask, and description is VR2 to VR1 link, no shutdown. There. I guess we're okay because the completion is 100%. So here, let's just exit. There. And lastly, what we need to do is check the connection of our two routers together. So for us to do that, we need to ping. We need to close this PC1. We need to ping PC2 and PC1. So same in our terminal. So here, okay, here we need to ping the IP address of our router 2, so 192.168.33.250, and as you can see, success rate is 80%. So it's successfully connected. Next, we need to ping PC2. We need to ping PC1 from PC2. So same procedure to the terminal. So here we need to ping the IP address of PC1, 168.33.249, and there. So now let's check on the results. There, we have completed everything. As you can see, the interface for gigabit 000 is already checked. We already fixed that. And I guess that's it.